Hi guys, this is a lovely old battery checker. It's branded Micronetta. No, Micronta? I don't know. Anyway, if we look at the label on the back, which I've started peeling off, and I'm rather annoyed that I've started doing that because the lettering is now falling off. But it does say this battery checker gives an instant something DC, AA, AAA, and 9-volt batteries. I do love this bit. A reading in the green zone indicates good. A reading in the red zone indicates dead. So that's simple enough. Green good, red dead. Replace. If the reading is in the yellow zone, the battery is weak and has limited life. This product checks zinc carbon, standard, alkaline, mercury and nickel cadmium when charged batteries. Note, check only one battery at a time. And the important bit, custom manufactured in Korea for Radio Shack, a division of the Tandy Corporation, Fort Worth, Texas, 76102. And just there, oh, Korea, that says, I thought that was another brand name, but no, that says Korea. Anyway, yeah, I've started peeling the label off because I wanted to see if I could feel there was screw holes under there, and the label is coming off quite nicely. But then I looked back at the label, and as I say, we've lost all the wording on it, so I'm quite upset about that. But we will have a look inside, see what we've got. This was inspired by ToyHacker, a channel that I enjoy watching. He did a little teardown, an analysis on a battery checker, a slightly more modern one than this, still a very basic one, but a little bit more modern than this one. Okay, let's see. Coming apart, there we go. A little bit crusty and dusty inside. I expect we could tidy that up a bit. So we have a resistor across the terminals for the 9-volt battery. That's where your 9-volt battery goes. Your AA and AAA, or AAA goes down in the slot, AA sits up here, and then your the bigger ones, the C's and D's, would go in here anyway. So that's your negative terminal, and that's your positives. So that's your spring loader, just to hold it in place. We've got a resistor in line on the positive side of the 9-volt supply. Then your AAA would be the bottom terminal there. So that's got another resistor in line going up. And then we got another resistor going between these two for the AA size and bigger. Yeah, so AA and bigger ones connect to there. AAA goes down the bottom there. So AA have got that resistor going to the negative, and that resistor going to the positive. Color wise, that's coming closer again. As long as the camera is not upsetting the color settings too much, that looks like brown, black, black. Would that be gold? I can't quite tell. And then this one looks like red, black, black, gold. This one Is that green or blue? Oh, it's red, blue, green, brown, and gold. Here, brown, blue, orange, gold, and that one, is that silver or grey or white? I really struggle to tell what these are. And green, brown. I could put a meter on them. The only thing I will say is my meters really are not very accurate when it comes to measuring resistances. They're good enough if you just want a general idea, but if you want an accurate measure. Oh, I do have another meter somewhere that I don't use. I'll go and have a look for it. Yeah, I keep forgetting about this one. Parkside, Lidl. I don't expect it to be top of the range, but it's possibly in better condition than the ones that I use on a regular basis. We'll try it. Nothing to lose. Oh, its leads are a bit springy. I hate them when they're like that. It's going to bounce around while we're trying to do things. Okay, resistance. Let's have a look if we get 0. Okay, that's good. Or 0.1 on the ohms range. So if we just go straight across this one, not measuring anything. Or are we? Oh, we are measuring 888. 0.888. Okay, so 890 ohms. Oh, we're moving around a little bit. Push a bit harder. 888. How about this one? Just over 1K, 1.075. .233K. 19.7 ohms. $10K. I'm not going to take that apart. Yeah, I think that'll do. It's got a series of digits up there. I wonder if that's 1983. Wouldn't surprise me. Anyway, yeah, that's it. We've had a peek inside. I don't know if that's all that ToyHacker was interested in. He did do more measurements and put power through them to check what was going on his. I'm not going to do that. That'll do. Let's just hold it up a bit closer. I've put together this circuit on Tinkercad so we can have a look at the current flow. I've got 3 push buttons on here so we can simulate the 3 different types of batteries we can fit. So the smallest battery would be a AAA, so we'd press that button to show it. Then the next battery would be a AA or a size C or a size D, so we press that button. And then the other one would be a 9-volt battery, which press that button to put it into circuit. So these are the resistors I looked at. And we've got a meter there that's set to amps at the moment. So if we start the simulation, at the moment all the switches are off. So we've got no amps, no current flow. If we press the 9-volt one, put that into circuit, we get 562 microamps. That one would be a AAA battery, 557 microamps. And that one would be a AA or C or D, 535 microamps. So they're all within the same sort of range. And if you imagine this meter being an analog meter with an arm flying across the face of it, then if they're all fairly close, which they are, then we'll get the same sort of reading if all the batteries are in good condition. I think that's the best way I can explain what's going on. So that'll do. So thanks for watching. Don't forget to like and subscribe. Leave us a comment so I know how I'm doing. And somewhere up here there'll be some links to related playlists. Thanks again.